Bine v-am regăsit, mă uit de cumii suntem, am intrat așa din prima în sală, fără prea multe gonguri, fără alte împulsături, să spun așa, de la spate. Mă speriasem că am rămas fără energie la jumătatea conferinței, dar lucrurile s-au reglat rapid. Zic că nu mai pierdem vremea și să deschidem al doilea panel, pentru că sunt extrem de multe lucruri extrem de interesante pe care le-am de abordat astăzi. Și pentru că tot vorbeam de abordare, vom discuta acum despre proiectări seismice cu elemente prefabricate în Italia. Și va veni aici pe scenă Susanna Comi, senior engineer structural. Aplauze, vă rog.
Good morning, everyone. Thanks for the invitation. I'm from Susanna, and we are an engineering company. We are a designer, and it's around 20 years that I work with Susanna, and with Susanna around 20 years ago, and here I started designing company. I came from the design part, so the executive part. I'm not really comfortable with the commercial part and so on. So I will go directly to the structural details. Okay, just a couple of words about who we are. We are a company that, as I said, we started precasting, designing precast with different precast with different factories since more than 30 years ago. So in all these years, we have quite a nice experience. You can read the number behind me. And we don't do only precast design, but also we have our time to start up new plans. We can say that we are the first Italian integrator of the prefab site. I mean, we both do the design, but we help to establish new factories. We did around 16 as a greenfield, so starting from zero, and almost the same number of improving existing structure. We say it as a brownfield. Now we are around 100 people all around the world, engineers, architects, on-site people, technicians, and so on. So this is the plan. In our experience, we define different types of precast construction. We have 7 strategies of residential building and 9 types of commercial building. In this presentation, I want to start with one specific industrial building that we think that is very seismic resilient. And then I will speak about the residential strategies as well, with the main focus of refurbishing, because as the previous speaker were speaking about, it's important also the ecological part of our job, because the future is also in that direction. So refurbishing the existing is the best way to reuse, not only recycle. And we will see our strategy that we are studying, that we are thinking about. Before starting with this, I want to present our company, showing you how we think. For example, when we have a client to establish a new plant or refurbish an existing one, which is the first and most thing. The first thing and the most important thing. The first thing is to think, to look around, to speak with our client, to understand which is our goal. This is the main thing. Before starting everything, we should understand why we do this, what we do. So, an market analysis company audit. It's feasibility, because maybe we have wonderful ideas, but are the right idea in the right place, in the right time? We should look at the future. The previous speakers said we have industry 0.4, 0.5. We have new technologies, but we have also an existing situation. The new plant or the refurbishing of a new plant where we start from and where we want to go. So this is the first important thing to understand. Obviously, after that, we go preliminary design. A precast system definition of there are a lot of type of precast system. We choose the one that we want to make in this factory. Study the joint, because the joint are one of the most important things in the precast. Then, when all the primary discussions are done, we start with the master plan and layout of the new stadium. So, we thought a lot. When the thinking is done, we start drawings, designing it, and then we fill the box of the master plan with real machinery. We can help with the machinery definition, the purchase support, and so on. Meanwhile, all the other needed things needed are text, performance analysis, and so on. Next step is people. It's important. We always speak about less people because obviously cost reasons. But it's important that the people we are inside our place, our family, our project, they should know and what they should do. So training is very, very important. It's important to have organization chart to understand which is the responsibility of each one, but also each figure should know his job. So training sales, training technician in the office, training people in production, training people to do the installation on the job, on the site. That is the detailing, and the job doesn't finish when we launch the new or the refurbished plan. The job goes on, and the follow-up is as important as the start. So this is the way of thinking that we apply in every job that we. Okay, let's quickly start with the precast industrial system. I think that most of you know the type of structure that I'm showing you. I want to concentrate on the skylight type. What is the skylight type of system? It is this kind of system. It is a sort of traditional construction system, but with a really big span. The span of this beam can go from 20 meters to 35 meters. So it's very interesting because aesthetically, because of the logistic reason, but it has also a nice seismic behavior. This is the production plan of the executive drawing and the production, a couple of pictures of production. The production is very standardized. It's sort of quick because it's all mesh down. It's all put the strands, mesh up, a bit of standard repair at the edge, and the piece is done. So, as you say, large span is sort of lightweight because the smallest, the most lightweight is around 100 kilograms per meter. The roofing. The biggest one, if you go on 35 meters, it will be a bit more, but anyway. As you can see, the main characteristic of this kind of building is a lot of light. It means that it's good for logistics, the old house, because it's big, but also for productive, because we have a lot of light. And a lot of light is energy improving. It is good because in the space between the two slabs, you can put solar panels, predefined models for solar panels. In Italy, we have, in the last years, we have a lot of need of solar panels. It's a traffic requirement. So this is perfect, it's matched perfectly. And always thinking about the future, so about energy savings, insulation. You can prepare the thermal insulation inside the V-shaped piece already in the production site. You don't have to do, you can, but you don't have to do it at 10 meters height and put insulation. On site, after you take it out of the mold, you can put the insulation and the finishing all there. So when you go on site, you take your big pieces, put the big heavy pieces, and you put it on the roofing and just close it with the shed models with solar panels or lights or windows, whatever it is. the other right in China is obvious durability, time efficiency, cost, quality control is typical of each precast situation. I choose this for my presentation because the seismic good behavior. I'm a structural engineer, so forgive me. This is for engineers. A typical building, industrial building in precast works dissipating the energy at the bottom of the column. And so the structure is not different from the other. What happens then? The beam column connection is a simple connection. It must be extremely simple, because if a connection is not simple in the analysis, in the calculation, in the design, on-site won't be done in the same way, because on-site we need to do simple things. So this way the connection is simple, and the sky beam allows us to have another simple connection. We consider it independent in calculation. But comparing it to other systems, this skylight is 2.5 meters wide. The width is 2.5 meters. So when there is an earthquake and it takes horizontal forces, you should imagine it is 35 meter length, for example, with a horizontal force in the middle, it won't have a movement out of plane. It has a lot of strength. You don't need bracing in the roof, because it's very strong. We saw it in 10 years ago in Italy. We have a sort of big quake in Emilia. This zone is a highly positive one. We have a lot of industrial building, and the behavior of this kind of element was very good, really good. When we speak about industrial system in Italy, and especially with this kind of system, there are two details that we must keep in mind. Always, we are always regarding this quake that has been last time 10 years ago. First is panels. In Italy, we like heavy panels, concrete panels from the top of the building to the bottom. It's a lot of weight. Is good or not with earthquake? The answer is, I think, with the first thing that I will show you. You must think twice. It's good, well, it can be done. You can do it if you manage to understand how they work and how to harmonize with the behavior of the structure. These two pictures at the bottom are taken after the earthquake of 12 years ago, some years ago, and it shows you some connection between panels and structure. In the first, the connection stand, the panel is gone away. In the second, the panel moved around 20 centimeters away from it. So which is the problem? What we do now? We think more. We have studied some connection that will work. So you can see a study. The first, on the top, you see the computer calculation software, and the second is the same building in reality. It's possible to do that. This one is a 20-meter high building, and the 14 in the lower part, made with thermal-insulated panels. And it is Bologna, so the second zone is quite high. It's possible, but you have to take care a lot of detail. You have to think more before starting. The second detail that I want to point out for seismic building, and especially sky building with that kind of business, is the foundation connection. You have columns that are 30 meters apart. Doing a connection in foundation is difficult, it's costly, and it's difficult because one thing is to work on a site with a lot of holes but nothing in the middle. If you start doing the connection, you have to cut this nice field with a lot of digging. For example, this building is the same as before. It is 40,000 square meters, and we need to do it quickly. So, if you look at the top part, it's already finished. In the part on this side, they finish the roof and they are preparing they are closing the roofing. On the other part, we are still putting in place the columns. With all these kinds of people going around, machinery going around, crane and so on, we could not do the cut for the connection from the connection beam for foundation. What we do in this kind of situation? We study more, we think more, we study details that can connect the wall. For example, this is an example of study to understand which are the details of the wall building, not only the foundation, of the wall building that can make it descend, and if during the earthquake, for example, there is a crack in the ground of 10 centimeters, if the columns move apart of 10 centimeters. So the result here was, okay, if we think more, if we think harder, we can find easy details that allows us to use elements that are not at the first glance that are not seismic. Instead, yes, we can manage to make it seismic too. Okay, and this is the first part for the industrial system. These one are instead the residential building system. Can I have a video, please? Okay. In our this time we define a lot of different type of building. For residential is more lighter, higher rise usually. The precast obviously has control cost, the staging performance and so on. But we have different type of system that follows different type of evolution, let's say. The first type that we will see, okay, the first type that we will see the most used everywhere is cut in place normal standard. Okay. The second step is to make it light industrial, but with a lot of level. The problem is not very seismic resistance, and the thickness of the floors is very high. So the next step will be use the walls, use the stairs as seismic resistant element, and make thinner. This is almost the same as before, but as you can see, there is the central stairs, and it's thinner with more, the details need a bit more study because you have no space. Okay. Next step. Okay. Next step will be build walls, shear resistant walls. We all had a presentation this morning about the advantages of this type of construction. In this wall you can put insulation, you can put everything. They have a wonderful seismic behavior and flexibility of layout because you don't have problem deciding the space and so on. This is another system. We use it, for example, for some villas in Naples near the volcano. It is almost the same as before, but it's totally dry. There is no second step casting. It's completely, totally dry. It's seismic resistant and totally dry. This is a new step. As you can see on the right, we have a modular system. In the plant is produced or U-shaped element or cubic element. It is, we should think more to make a nice building. You can do high-rise building or small villas, depend on the style of, on the fantasy of the architect we can see. Anyway, this is a quick, let's say, a quick overview of our structural system for residential. I want to point out this one that I don't put in the previous video. What is this? This is the one that I was speaking about before. It is not a new way of construction, but it's a refurbishing of existing building. In Italy, we have a lot of building, residential building done around, in the boom economic period. So now they are 40, 50 years old, not very thermal, with a low thermal proficiency. Maybe the seismic regulation in the last 40 years changed. So what is the best ecological thing to do? Is to keep the same building and refurbish it. Okay. And this is the skeleton technology that we are studying, that we are proving. What is it? We prepare panels that consist in structural layer, insulation layer, predisposition for pipes, plumbing, electricity, whatever, and finishing. And in the mold, we put also, for example, windows. Everything is already done in our precast plant. We can, so the time, we divide the three parts. First, study, because to reach this, we must totally study a lot before. We must film. Maybe we can use the video while I explain. Thank you. We must study a lot because all the things that we said, beam, technology 4.0, if you don't have already a high informative system, you cannot reach it. Yeah, because as we say, the design part is one of the most important. As you see, this is a typical old building, residential building area with a lot of thermal dispersion, low seismic performance, and so on. What we want is to renew it, maybe also without asking people to go away from a couple of years, because if I refurbish a building like this, there are 20, 40 families inside, I cannot tell you, please go away. So, first phase is study. Study and assessment means that we should know everything about this building. The geometry, the materials, we should test it, use BIM design. Use BIM design also because we speak with the plant, the people who study plant, installation, mechanical, everything must be decided before starting. So it's the most important part. Then we prepare this magic panel in some situation, maybe we don't need the staging part. In some situation you need. Typically the vertical load is taken by the old structure, the horizontal load from the seismic is taken by the walls. We prepare in our factory also the technologies, the heating, cooling, photovoltaic, and we prepare everything in factory. In factory we have a better control of the process. It means less time, less materials also. Or it's very the biggest optimization that we can do. We bring on-site this part already prepared. As I said, you already have windows inside here, everything, and just, well, the walls are there anyway, apply this on the existing wall. The connection must be started and so on. So the time that you work on the real building are very short. Okay. You can do a bit of reinforcement of the foundation, and everything is clear. Everything is integrated. There are different levels to apply this technology. You can do a full refurbishing seismic terminals. Maybe you need something on some part. Maybe you apply it on some walls and some other you can do it on site. As we said, it depends on the condition, of the situation, and of what we want. Those are the benefits that we obviously have. And this is our what we are studying right now. Okay, you can stop the video, please. This is what we stated before, with a strong accent about energy saving, and to reach this we need a new technology. Okay, just a picture of the real thing. This is the building that we are doing now. This is a panel. If you see, there is already inside the window the glass of the window. And this is the part of the executive drawing. Okay, that's all. I hope that I didn't annoy you. Thanks everyone.
My name is Andrea Căsuță from UTCB. Thank you for your presentation. I just have one question. How do you validate your seismic resistance? So you said several times that your systems are seismic resistant. How do you validate them? Do you make experiments? Do you make, of course, earthquake proofs, or what else?
Okay. Mostly we validate with existing codes. I mean, all these kind of buildings have a code. We just started the, for example, the V building, the skylight building. They are standard building with improved detail. When I see we validate it, there are a lot of earthquakes. So we can see also the result. It's one thing the code validation of the code, and one thing the result. Also the previous building were done according to the code. But for example, the quake in the Emilia, the acceleration was in some zone 20-30% higher than the code. And so it has been a good benchmark. Some residential building, we use it after the L'Aquila quake in always in Italy around 5 years ago. So there is a two-side of relation. One, the existing code, Italian code, not only your code, also in other American code, depending on where we are going. And second, we look at the piece. Since the 20 years that we are around, we have jobs that we did 20 years ago, jobs that we did 5 years ago, and we like to follow up this. So it's important. Instead, for the last part, it's, we are studying it. Actually, we are already studying it. We are calculating it with the seismic resistance thin panel, that is a part of the Euro code, a part of Italian code, and we are studying it with this. The test and so on, we are going to validate during the time.
Okay, so you mean you will do experiments for your proposal, your new proposal?
Only when it goes really outside of the code. Because mostly is taking the existing code and, as I say, thinking twice.
Okay, thank you very much.
No problem.